All right, so today we are going to be talking about naming compounds and writing chemical formulas. So to start off this, we're just going to talk about naming ions. Naming a positive ion, pretty easy. Basically, the element keeps its name. The word ion is added at the end. So the example here, we've got a sodium atom, loses an electron to get that positive charge, it becomes a sodium ion. Pretty easy. Negative ions, right? Not too much more difficult. So in this one, when it becomes a negative ion, the ending of the element name is dropped, the suffix "ide" is added, and the word ion is placed after it. Right? This is one that I'm sure you're familiar with, even if you don't recognize it at the moment. But things like fluoride, I'm sure you are familiar with that. Probably even fluoride. And so in this, right, we've got a fluorine atom. It gains an electron to get that negative charge. Then we just call it a fluoride ion. So naming simple ionic compounds, pretty easy. So to start off with, I'll tell you simple ionic compounds are compounds that are just composed of a metal cation and a non-metal ion. Right? You've got two elements. One of them is a metal. It's going to be positive in its charge. One of them is a non-metal. It's going to have a negative charge. And then to name the compound, the names of the ions are simply combined without the word ion. Right? A sodium ion and a chloride ion combine to form sodium chloride, chemical that I'm quite sure you're all familiar with. And for simple ionic, that's about as difficult as it gets. We talk a little bit about when they have subscripts, but the subscripts for simple ionic are not going to change the name at all, unless the element, unless your metal is in the D block, but we will talk about that later in the video. So writing formulas for simple ionic, writing the chemical formula for an ionic compound, the elemental symbol for each ion has to be written, and the positive ion always appears first in the formula. Same with the name, your positive cation is always going to be first. When writing the formulas, you also have to consider the charges on each ion, and you have to balance the amount of positive and negative charge so that overall your compound is neutral. And basically you're going to do this by adding one or more to possibly both of the ions, maybe just one of them, and indicating the number of ions present with a subscript number. If you don't remember how to find the charges, right, up above the columns on your periodic table, you'll see things written like this. Right, and that's going to indicate the charge of anything in those columns when it is, and stop working for a second. Right, so anything in these columns, that's going to be the charge. Right, so anything in the S or E block, right, that's going to be the charge. The D block here in the middle, that gets a little different, but we will go through that and figure out how to figure out their charges. So for some examples, let's start out going formula to name. Let's see if I had something like Na3N. Right, we look at these Na, sodium, 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 and then N, we know that's nitrogen, right? But the fact that it's second, we know it has to have a negative charge. Remember, negative ions, the ide ending. Instead of sodium nitrogen, we would have sodium nitride. Hopefully That makes some sense. Or let's go Li2O. Right, we have this formula. We look at Li, you can find that that is lithium. And then O, we know that that's oxygen. We're going to drop the ending for oxygen because it's second. We know negative. Drop it there. Right. We have lithium oxide. Right. Had several people try to cut it here and give me lithium oxide in the past. Just remember, not oxide, is oxide. So drop the ending, put "ide" on for the negative. So on the other side, let's take a look at writing some formulas. We have, say, bromide. Right, we look at the elements here. Magnesium, find it on the periodic table, is Mg. Up at the top of the column, +2 charge. We look at bromide. Remember that the ending has been changed because it's the second element in the compound. So we look, that's bromine, R, got a charge of -1. So here we look, right, charges are not balanced. +2 over here, -1 over here. So before we can write the final formula, right, you can't just write MgBr, the charges are not balanced. We have to balance the charges. We're going to use subscripts. And a really easy trick to figure out what the subscripts are, just take the numbers here, right, not the plus or minus, just the numbers. Use them as the subscript for the opposite element. End up with Mg1, Br2. We're going to clean this up even a little more because here, right, Mg, it doesn't need the 1. The fact that you wrote Mg here means that I know you have at least 1 magnesium. So your final formula, like Mg Br2. That is the formula for magnesium bromide. Now, let's take a look at, let's say, aluminum sulfide. All right, so if we look, we can find that aluminum on the periodic table, Al, at the top of the column, we see that it's +3. Sulfide, remember the ending change, sulfur, 2. Again, we have to balance the charges so that we can just bring groups down. Have Al, whoops, sorry, wrong. Al2, S3. Right, before we say that this is completely done, we need to check, see if we can reduce our subscripts, because if we can, we have to. Right? In this case, 2 and 3, there's no common factor besides 1, which just leave us with 2 and 3 again. So we're going to leave it as it is, but remember that if you can reduce these, then you need to. Okay, so now we're going to get into naming and formulas for compounds with transition metals. So like I said, no common charges listed in the D block is because each of them have more than one common charge. So in this case, you're going to need to put a Roman numeral. Right? Hopefully you all remember your Roman numerals. Right, we've got to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. those are your Roman numerals. And that's going to go in the name to indicate the charge, the ion. Right? So if you're given the name and you're trying to figure out the formula, it will have a Roman numeral in it, and that is going to be the charge of your metal. Right? So, but if you're just given the formula, you're going to have to figure out the charge based on the charge of your negative ion. Take a look. So the first one, do name, like maybe iron 3 oxide. We're going to do this just like simple ionic. We find iron, it's Fe. And here, right, the 3 is telling us the charge. And oxide, oxygen, -2. Again, we use the same trick. 3 will come down here, 2 here. Fe2O3. Check. Our subscripts can't be reduced. All there is to it. On the other hand, if we are given a formula, let's say vanadium, nitrogen, so let's say we have something like this, right? We've got VN2. So now we need to look. Vanadium, find V on the periodic table. We know we're going to need a Roman numeral because it's in the D block. And we have nitrogen as our negative ion, so we know we have bride. Right, this has no charge on the periodic table. So we're going to have to look at what nitrogen has for a charge. So if we look, we find that nitride has -3. And so here we look at the subscript. We have 2 nitrides, each with a -3 charge. Right? So basically, 2 times -3 is 6. Right? And so we know that if this is -6, the vanadium here has to be +6. We look for a subscript, 1, right, or nothing. So we know that there's just one vanadium. Each vanadium has to have a charge of +6. So we then write vanadium 6 nitride. That is how you figure out the charge on your transition. Okay, so the last thing here, polyatomic ions, right? These are ions that contain more than one atom, named polyatomic, but still have a charge. So you can identify them in a formula, do simple things. They will always have more than one element in them. So if your ionic compound has 2 than more elements, or more than 2 elements present, it contains a polyatomic ion. Polyatomic ions usually have 2 or more nonmetals bonded together. So if your ionic compound contains more than one nonmetal, it contains a polyatomic ion. And then the last thing, if more than one polyatomic ion is needed to balance the charge of the compound, it will be in parentheses with the subscripts outside. So take a look at some naming formulas for these. Oops, draw that. So if we look at, let's say, calcium nitrate. All right, we can find calcium on the periodic table, Ca, +2 charge. Here's the thing, nitrate. You're going to have to look in the little box in the periodic table packet that I gave you that says polyatomic ions. If you look, nitrate, NO3, and it has a -1 charge. Okay, so now, right, just like in a simple ionic, you can take the numbers, use them as subscripts, right? But if we just write these without parentheses, right, it looks like we have NO32. That is not what we want. We want two NO3s, right? So you have to put those parentheses before you put your subscript. Again, you don't need the 1. Get rid of that. And so there we go. Calcium nitrate, CaNO3, 2. So you will have a list of polyatomic ions there. I will not ask you about ones that are not in there. So that's going from name to formula. Then if we want to go formula to name, maybe we have meant for that to be A2. All right, so looking at this, we're starting out with lithium. All right, we know it's lithium. It's a single element because we've got capital letter, lowercase letter. We know we have lithium. And then this, we have S and O. We can tell that it's 2 elements because there's 2 capital letters. We've got this 4 subscript out here. So when you look SO4, that is sulfate. We check to see if lithium is in the D block. It is not. So we do not need a Roman numeral. It means that we are done, and the name of this is lithium sulfate. So for wrapping up here, some things to remember. Ionic compounds are made from a metal and a nonmetal. The cation is always the first element in both the name and the formula. The charges of any ions present must be balanced so that the overall charge of the compound is 0. Any metal in the D block, right, which I will refer to as a transition metal, needs a Roman numeral in the compound name. And the Roman numeral indicates the charge of that ion, right? So if you see a Roman numeral in the name, that means that is the charge of the metal. Polyatomic ions, these can be identified by looking for either more than 2 elements in an ionic compound or 2 or more non-metals in an ionic compound, right? And either way, you're going to end up with more than 2 elements in your compound. So hopefully that will get you started. There's definitely some practice up. This is something that really, the only thing that helps is practice. Practice, practice. The more you do it, the more it will seem make sense. So go, do some practice. I will see you back in class.